Hello, everyone. The last video was getting a little too long, so I decided to cut it and continue here. We were talking about bonding. We did ionic and nonpolar in the last video. This last segment will be on polar covalent bonds. Remember that when something is a polar covalent bond, it's going to be made up of two nonmetals, which means the electrons are going to be shared unequally. When this occurs, our electronegativity difference is going to be between 0.5 and 1.6 when we look it up and do our math. When we draw the structures out, they are going to be asymmetrical, which means they're going to be not equal on all the sides. And when I look at the charges, I'm going to see opposite charges if I were to place them in the mix. So again, we're relating this to solutions with like dissolves like. So it's important to understand what is polar, what's nonpolar, and what's ionic. So these three examples will be polar covalent. Let's check them out. The first example is H2O. By now, you should know water is always polar, but we're going to prove that in our analysis. First, going to my periodic table, remember that hydrogen, moving myself out of the way, is top left. Remember, that's a nonmetal, reacting with oxygen, which is a nonmetal. So I have two nonmetals. And when I go to the electronegativities, H is 2.2, O is 3.4, and that's going to give me a difference of 0.8. Now notice 0.8 is in this region of 0.5 to 1.6, proving that it's going to be polar. But we want to get the complete picture and analyze the drawing. Now again, the drawing is going to pop up, but you should remember that you know how to draw these with your Lewis dot diagrams. So here I have my water molecule, and notice when it's looked at, when it's drawn correctly, it's asymmetrical. It's not equal on all the sides. We can prove that. The bottom half has the H's, the top half has the electrons. These Lewis dots are your valence electrons. Therefore, it's not equal on all sides. Also, we can look at the charges. If I go to my reference table, H has a positive charge, so positive, positive down here, but the Lewis dots are electrons, and the electrons have a negative charge, so negative, positive gives it an opposite charge. Polar covalent bonds are going to exhibit those key points. In our second example, we're going to look at HCl. So first thing is, if we look at the periodic table, H, top left, Cl, top right, I know I have two nonmetals. If I go to table S, H has a value of 2.2 and Cl has a value of 3.2. So when I do the math, I'm going to get 2.2 and 3.2. Subtracting those will give me an electronegativity difference of 1.0. 1.0 also falls in the region of 0.5 to 1.6. Lastly, when I look at the diagram of hydrogen chloride or hydrochloric acid, HCl, I can see that it is not equal. Notice I have only an H on this side, but on the other side, I have Cl with all of these extra Lewis dot valence electrons. So it's not equal. If I look at the charges, H has a positive charge, Cl has a negative charge, so I'm going to have opposite charges, again, making it polar. Again, not hard to do, but it does require some work. The last example that we're going to look at is NH3. NH3, again, N is on the top right, H is on the top left, it's my nonmetal. When I go to table S, N has a value of 3.0. H has a value of 2.2. So I have my two nonmetals, 3.0 and 2.2. That's going to give me a difference of 0.8. 0.8 also falls in that range for polar covalent. And when I look at my structure, I can see again, something is missing here. So it's not equal on all sides. It is asymmetrical. Same thing with the charges. H is positive, positive, positive. That looks pretty good. But then I have these two Lewis dot valence electrons that are negative, which makes it plus, minus, plus, minus, plus, minus. Again, the whole purpose of reviewing the bonding today is to help you with the worksheet on solutions with like dissolves like. Ionic will dissolve in something polar because they're both plus minus. Polar dissolves in polar. Non-polar dissolves in non-polar. So we need to understand what something is by looking at it. And sometimes we'll have to go through the whole process, looking up electronegativity values, doing my subtraction, and then lastly, drawing the molecule. Practice these. Try to remember them because these are your most common examples when you're asked about solution chemistry. Again, review your bonding notes, review your bonding videos, and everything should work out okay. Have a good day.